Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 8 of a unit system of particles and rotational motion. So let's begin with today's class. In today's class, initially we are going to discuss about the center of gravity and then we will discuss about the equilibrium. So let's first begin with the center of gravity. What it is, let's have a look. We can say a rigid body can be considered as consisting of a large number of particles. When it is having a large number of particles, a gravitational force act on each particle in vertically downward direction. Since the center of the earth is at large distance from the surface, so this force is due to gravity can be considered as parallel to each other. The resultant of all this force is equal to the total weight of the body. So this is about the weight of the body. Yes, and we can say this, the weight is directed in vertically downward direction through a point that we call as a center of mass on a body. Yes, this is the situation that can be seen like this, that different particles are there, and on this different particles a force of gravity is acting, and this all forces can be considered as parallel to each other, that you can see in the diagram as well. So we can say that center of gravity of a body is a point at which the total weight of the body acts vertically downward for any position of the body. So it is the location, or we can say it is the point of the body at which we assume that total weight of the body is concentrated over here. Now, if the shape of a body is symmetrical and density is uniform, in this case center of mass and center of gravity of a body coincides each other. So if my body is symmetrical and its density is uniform, sorry, then the center of gravity and center of mass would be lying at the same location. And we can say that center of gravity is the at the point of symmetry. It means at the geometrical center. They are talking about something like this, that let's say a square road, rectangular road is there, and if I look at the center of mass of this road, it is at this position. If I look for the center of gravity of this road, even it would be at this location. So in this kind of situation, center of gravity would be at the same location where center of mass is. I hope this is clear. Yes. So center of gravity and center of mass of triangular lamina is situated at its centroid. Center of gravity of uniform ring is at its center. So these are the different examples where center of mass and center of gravity coincides. So for all the small bodies, when we say small bodies, that we are comparing this with the size of the earth, the center of gravity and center of the mass coincides. Yes. So what is the practical application of center of gravity? We used to avoid the overturning of the vehicle by moving on a curved road. The height of the center of gravity of the vehicle should be nearer to the ground. Yes. So if it is nearer to the ground, that means it is going to be attached with the ground, and there would be a less probability or the less chances of the overturning of the vehicle. Let's see this, a different situation in circus. A person walking on a stretch horizontal rope changes his orientation such that the line of the action of the total weight passes vertically within the base area, and thus he can manages himself to walking on the rope. Even the joker, or we can say it's a juggler is doing the same thing. Yes, it is keep rotating his arms as well as his legs, so that a center of gravity will allow him to to juggle the balls. I hope this is clear. Is it clear? Is it? Is it clear? Great. Let's discuss the equilibrium of a body. What equilibrium is and how does it relate when I talk this in the system of particle and rotational motion. So let's begin. So first, what is equilibrium? We can say that a rigid body acted upon by several forces in different directions neither possesses translational motion nor rotatory motion, then it is said to be in equilibrium, or I should say this, it is in a mechanical equilibrium. That means a rigid body is said to be in mechanical equilibrium if both its linear momentum and angular momentum are not changing with respect to time, or the body has neither linear acceleration nor angular acceleration. For this two laws are to be satisfied. So what we want that body should not be having a translatory motion, as well as it should not be having any rotational motion. If this is the situation, that it doesn't have translatory motion, it doesn't have rotational motion, then the body is said to be in equilibrium. So we can say that it is if the vector summation, it's a vector sum of the forces on the rigid body is 0, then I can understood that F1 plus F2 plus F3 up to Fn is equals to 0. So this is sigma Fi, addition of all the forces should be equals to 0. And if this law is satisfied, and the total linear momentum of the body does not change with time, then it gives the condition for the translational equilibrium of the body to be 0. I hope this is clear. So this is the first condition. To after satisfying this, we understand that body does not have any translatory motion. Now let's check the second condition. The vector sum of all the torques on the rigid body must be 0. So it's a torque 1 plus torque 2 plus torque n. Its addition of every torque should be a 0. If this law is satisfied, then the total angular momentum of the body does not change with time, and this will give me the condition for the rotational equilibrium of the body, and it does not depend on the location of the origin about which torques are taken. So when they said me that your system is in equilibrium, what I need to understand is that I'm having a two motion, it's in translatory motion, and the another is the rotational motion. When they talk for the equilibrium, what I need to do is for the translatory motion, for the translatory equilibrium, my all the forces should be equals to 0. I'm talking about the vector addition of the forces, that is for sure. Yes, so the addition of all the forces should be equals to 0, and for rotational equilibrium, addition of all the torque should be equals to 0. If I can achieve this, the things will be done. I hope this is clear. Is it clear? So let's look at the questions, how the questions has been asked, and how can we deal with it. So let's have it. Let's suppose a road is there, and it has been provided a support with this two edges. So what they want? They want that find out normal reaction provided by this two supports. Yes, the mass of the road, it's a 10 kg. Length of the road, it's a 10 meter. Yes. So how will I do this? What can be done? What can be done? What do you think? What I need to do is that find out normal reaction provided by this 2. Suppose one more thing they have provided is that assume that system is in equilibrium. That system is in equilibrium, mass of the road is given, length of the road is given, and this 2 supports has been provided at the end of the road. So what I need to do is that this is the road, this is the first support, this is the second support, and this must be the location of the mg. Yes, this mg must be acting in this direction. Normal 1 acting in this direction, normal due to this is acting in this direction. This must be the midpoint, so this is 5 meter, even this is 5 meter. Yes. So now what I need to do is that let's understand that first the translatory equilibrium. So it's a sigma forces is equals to 0. If I write this sigma forces is equals to 0, then I could have this, it's an n1 plus n2, that should be is equals to mng. Mass, it's a 10 kg, so this is n1 plus n2, that should be equals to 10 tens, it's in 100 newton. I hope this is clear. So this n1 plus this n2 will make 100 newton for me. Does it clear? Does it clear? This is the just the first relation, because I have satisfied up till now only one condition, that is the total force acting on it must be a 0. Now let's work for the second condition, but before I draw it I require the diagram. This was n1, this was n2. At the midpoint it was the mg that is acting. This is phi and this is phi. Yes. So let's consider that let's give it name as upon. So sigma torque at point 1 equals to 0. Let's assume that torque at point 1 or all the torques acting on this at point 1 would be equals to 0. So who will provide me the torque? First, torque due to mg is 0. Torque due to mg is 0, that is for sure. Now torque due to n1, what is it? It's an n1 is the force multiplied by perpendicular distance, this is phi. Torque due to n2, it's an n2 is the force multiplied by phi is the perpendicular distance. Now as n1, this force can rotate, this n1 can rotate it in clockwise direction, and while it is rotating in clockwise direction, this should be the negative. This n2 is going to rotate it, into the anti-clockwise direction, so this will be the positive. So if I write sigma torque is equals to 0, I should write it's a minus of n1 into phi plus n2 into phi, that should be equals to 0. So that is n1 equals to n2. I hope this is clear. This is relation number 2. Now I have first relation, which was n1 plus n2 is equals to 100. So this is 2n is equals to 100, and this n equals to 50 newton. I hope this is clear. Yes, this n1, or I should say n2, that is equals to 50 newton. I hope this is clear. Is it clear? Is it? So can you calculate it on your own? Are you sure? Let's have a look then. The question is something like this. A road is there. This is having mass of 10 kg. Let me write down here. It's a mass of 10 kg. Length, it's a 10 meter. Support, one of the support is here. This is the midpoint. and the another support is here. This is 2 meter. One of the force is acting over here, it's a 2 meter, and this force is of 10 newton. This force is of 20 newton. Yes. So what they want, that find out normal forces provided by both the supports if system is in equilibrium. So let's begin then. First, what I need to write is the sigma forces is equals to 0. So if I'm going to write this, that sigma forces will be equals to 0, what I understand is this is the first force, this is the second force. Let give them a name. It's an F1, it's an F2. This will provide me the normal one, this will provide me the normal 2, and here it will be the mg. So what I need to do is all the forces that are acting on the downward side, they are the 10 newton, 20 newton and mg. It's a 10 plus 20 plus mg. That should be equals to, is equals to, this is normal 1, this is normal 2. It's an n1 plus n2. So it's a 10 plus 20, 30 plus m. It's a 10 plus 10, it's an 100, is equals to n1 plus n2. And this will give me an n1 plus n2, which is equals to 130 newton. I hope this is clear. Is it clear? Is it any doubts? Is there anything? No? So does it clear up till now? Does it? Great. Now let's work for the second condition, but before we go for it, we need to have a diagram of it. So n1 was acting on this, n2 were acting like this. This was 2 meter. This is the midpoint. So this is 5 meter, and this is 5 meter. Force F1 is acting in this, and this is 2 meter. This is F2, which is equals to 20, and here mg is acting. So let's give it a name. Let's give it a name that this is location 1. Sigma torque at 1 will be equals to 0. So who will provide me the torque? First, torque due to F2, what it would be? Torque due to F2, what it would be? How much torque it can provide? Torque due to F2, I should say it's a 0. Why? Because it is acting on the same point. Great. Next, torque due to mg, how much? It's a 0. Great. So torque due to these two forces would be 0. Now let's find out the torque due to other forces. The torque due to n1, how much? Yes, it's an n1 multiplied by 5. Next, torque due to f1, that is equals to f1 multiplied by, look at this, this is 2 meter, it means this must be the 3 meter, so it's a f1 into 3. Next, torque due to n2, this is equals to n2 into, this is 2 meter, so it means this is 3 meter. It's a torque due to n2. Anything else left? Does it? No. Great. So let's find out the direction as well. Torque due to n1, it will rotate it in clockwise, so this will be the negative. Torque due to f1, it will rotate it into the anti-clockwise, it will be the positive. And torque due to n2, again it is rotating into the anti-clockwise, so this will be the positive. So this net torque would be equals to 0. That means it's an n2 into 3 plus f1. the value of F1 was the 10. It's a 10 into 3. That should be is equals to N1 into 5. So this is equals to 3 and 2 minus of 5 and 1. This is equals to 10 3s are 30. This is relation number 2. Yes, we have a first relation. We have first relation was it's an N2 plus N1 which is equals to 130, but this was minus of 30. So let's just solve this in the next slide. It says that it's an N2 plus N1 which is equals to 130 Newton, and the second it's a 3 and 2 minus of 5 and 1 is equals to minus of 30 Newton. So what we can do is we can just multiply this. It's a 5 and 2 plus 5 and 1 is equals to 130 into 5. So this could be cancelled out. 5 and 2 plus 3 and 2, it's an 8 and 2 which is equals to 130 multiplied by 5. It's a 13 5s are 65. It's a 650 minus 30. So this is equals to 650 minus 30 which is a 620. So this N2 would be equals to 620 by 8. Yes, this can be reduced definitely. It's a 310 divided by 4. If again it's 155 divided by 2 and 155. So it's a 75 2s are 150 and 77.5 Newton. This is N2. This is N2. If I put it this, it's an N2 plus N1 is equals to 130 Newton. So this is 77.5 plus N1 which is equals to 130. So this N1 is equals to 130 minus 77.5. So the 77.5 and 130, what is the difference? It's a 77.5 plus 2.5, it's an 80. 80 plus 50, 30. Yes, so this is equals to 52.5 Newton. I hope this is clear. Got it? So can it be done? Can it be? Are you sure? Can it be done by you guys? Are you sure? Are you? Okay, great. So let's work for the next question. It is again it is going to be the same question based on the equilibrium, or I should say it's a mechanical equilibrium. So in this question the situation would be something like this, that this is one of the wall. Let me redraw. And this is the floor, and the situation is that a ladder is there, and this ladder is lying at something like this. Yes, this floor is having friction, so the coefficient of friction is mu, and this wall does not have any friction, so I have written it as a mu is equals to 0. So let's assume this is the angle theta. This you can see as a 90 degree. So the question is find condition of equilibrium such that ladder cannot have translatory or rotational motion. So this is the situation. How will we do this? How could I? So what I understand is, let's first write it down, all the forces that are acting on this. So we understand that this ladder is having mass m and this ladder is having length of L. So mass m is there, length L is there, and this ladder is resting with this help of support of the wall and the floor. So this is the midpoint, and if this is the midpoint, mg would be acting on this. Let's say a normal has been acting on this. This would be the normal due to 2. A normal one will be provided by this. This will be the normal one. And if the leader is trying to move, if the leader is trying to move in positive x direction, I need to apply a friction in this direction. So this is friction. I hope this is clear. So for translatory equilibrium, I could say for translatory equilibrium, it's an sigma forces in horizontal direction would be equals to 0 first. So in horizontal direction I am having an n2 in positive x direction and f in negative x direction, so I can have it's an n2 is equals to friction. And for translatory equilibrium, sigma forces in vertical direction must be equals to 0. So in vertical direction n1 is acting, in positive y direction, mg is acting in negative y direction, so this n1 must be is equals to mg. Yes, this is the relation 1 and 1 dash. I hope this is clear. So up till now we have done only the translatory equilibrium. Now it's a time for the rotational equilibrium. Let's have a look. This is y, this is x. This was the leader, and we have n1 over here, n2 over here, mg at the midpoint, and this is the angle theta, as this is with friction. So now for rotational equilibrium, how will we do this? How could I? So what I understood is I need to choose any one of the point. I need to choose any one of the point where I can take that net torque on that point would be 0. So which point should be considered? Which point should be considered? So let we discuss first. Let's suppose if this has been chosen as a first point, then what I understand is that if this has been chosen, if first point has been chosen, then torque due to n2 will be equals to 0. So only one of the torque can be written as a 0. A second point, if this has been chosen, then torque due to mg could be written as 0. We are just deciding that what to choose as the net torque 0. And let's say this is the third point. Then if third point is there, then torque due to n1 will be equals to 0 and torque due to friction will be 0. So if I analysis this, then I understand that if I choose this location for the net torque to be 0, then the calculation would be easier, because the two forces can be two torque due to two forces can be converted to 0. So let's choose this and let's cancel this ideas. That what I am supposed to do is that torque at, let's write this, it's a torque at location 3. So torque at 3 would be equals to 0. So torque due to friction 0, torque due to n1 would be 0. Great. Now torque due to n2, how will I do this? So first let's understand that this is the length L. This is the angle theta. So what I need to do is, this is L cos theta and this is L sin theta. Now tell me which component is parallel. Which component is parallel and which component is perpendicular. So for n2 L sine theta will work as the perpendicular distance. So this torque due to n2 would be equals to n2 into L sine theta. Great. Now let's talk about the torque due to mg. As I understand that this would be the L by 2, half of the distance. So mg, for the mg, this will be the perpendicular distance. It's an L by 2 cos theta. So this is equals to mg multiplied by L by 2 cos theta. I hope this is clear. Is it clear? Is it? Now is there anything left? No. So what I need to do is I need to find out the direction. Torque due to n2. In which direction? In which direction? Yes, it is rotating it into the clockwise direction. So this should be taken as a negative. And mg is rotating in anti-clockwise direction. So this should be taken as a positive. So what I can write, it's an mg into L by 2 cos theta. That is equals to n2 into L sine theta. So this L could be gone, and what I can have, it's an n, let's say mg is equals to 2n2 into sine theta by cos theta, which is equals to tan theta. This is relation number 3. I hope this is clear. Now you have a value of everything. And from that you can find out the rest amount of thing. But do you understand the approach? Are you clear with it? So please practice this kind of questions. It will help us. Yes? Do you have any concern, any doubts over this? Anything? Is there anything? Is there? No? Great. Let's discuss the radius of gyration of a body. So let's discuss what is it and how to use it. We can say that radius of gyration, it is a measure of the way in which the mass of rotating body is distributed about the axis of rotation. We define this quantity that we call as a radius of gyration. So as the name suggests, its name suggests that it represents the length, and as it represents the length, it has the unit of meter, and when it is having a unit of meter, it is having a dimensions, that is m0, l1, t0. Yes, so what does it actually mean? Because the definition is quite confusing, that what is gyration and why to use it. Let's have a look. Let's suppose what we understood is that this is object M and this is my rotational axis. So the distance of the rotational axis and this object is the k. So it's a distance between the axis of rotation and the point at which the whole mass of the body is assumed to be concentrated. It's in k. So for this body, I can define radius of gyration. It is equals to m into k square, where k is said to as it's a radius of gyration. So what I'm supposed to do is, let's suppose understood that my moment of inertia of the system is I is equals to mr square, and I want the radius of gyration. Of this system. What I need to do is my total moment of inertia needs to be compared with m into k square. Yes, it is as simple as that. So in this case, this mk square could be equals to mr square. So in this situation, k would be equals to r, and that's it. You did it. Great job. I hope this is clear. Is it clear? So why I define this? Because when and when we need to discuss the rolling motion, there are certain cases that we cannot define as different parameters for different objects. Let's say we cannot define it like a kinetic energy of sphere is this, kinetic energy of ring is this, kinetic energy of hollow sphere is this. instead of that, we are going to define this in the terms of the k square by r square, and that makes our study very easy, very quick, and very easy to understand. Yes, that's why we define this. Now, this is our requirement. What is the definition of radius of gyration? What we are supposed to understand is that, let's suppose we have a certain body, something like this, and this body is being rotated from this rotational axis. Let's say this is the center of mass. This is the center of mass of this body. Let's give it a name m, and this is the distance between the rotational axis and the center of mass k. So I can define this. I can define this as, if this body rotates from COM, then its moment of inertia can be given as I is equals to mk square. So this k represents radius of gyration. Is it clear? Is it? This k represents the radius of gyration. Now, does it clear? Does it? Great. Let's have certain questions based on this, and this thing will be more clearer to you. Let's look at this. Let's suppose a certain object is there, and this object is having mass of 10 kg, and its moment of inertia I has been given, which is equals to 360 kg into meter square. I need to find out the value of k. Gyration is required. So what I understood is that this could be the center of mass, and it is having a mass of 10 kg. Now the data, according to the data given, it is at the 6 meter from the axis of rotation. I have been given moment of inertia, that is I is given, which is equals to 360 kg into meter square. And if this has been given, let's compare it with m into k square. So this is equals to 360 is equals to 10 into k square. K square is equals to 36. This has been gone, and that's why radius of gyration k would be equals to 6 meter. That's it. I hope this is clear. Yes, this is what I am looking for. It's an I is equals to mk square. Yes, great. Let's look at the next question. It says that the radius of gyration of moment of inertia 50 kg meter square and mass 10 kg. So I is equals to m into k square. Moment of inertia, it's a 50, mass is the 10. This is equals to 10 k square. So this k square, that should be is equals to 50 by 10, that is equals to 5. And while writing 5, it's a k should be is equals to root of 5. That's it. Yes, unit definitely would be there. It would be a root of 5 meter. So now, does it make sense and does it make clear? Is it clear? Do you understand this stuff? Are you sure? Are you sure? Great. Let's work for the next question. It says that if complete mass is supposed to be concentrated on a single point with same mi, with same moment of inertia about the axis of rotation, then the distance of that point mass from the axis, this is we call as a radius of gyration. You can remember this as a definition of the radius of gyration. It is that location that if complete mass is supposed to be concentrated on that point with same mi, with moment of inertia would remain the same about the same axis of rotation, then distance of that point mass from the axis of rotation is called as the radius of gyration. I hope this is clear. Great. Let's work for the next question. The radius of gyration k is 5 meter with its mass 10 kg. I need to find out the moment of inertia. So I can write like this. It's that I is equals to m into k square. Mass, it's a 10. K, it's a 5 square, 25. This would be 250 kg into meter square. That's it. You did it. Great job. I hope this is clear. Is it clear? Is it? So let's have some more practice. Let's say one of the road is given and it is being rotated from this. So they say that find out radius of gyration for given situation. This is first. So what I need to do, I need to do only the moment of inertia, and that moment of inertia needs to be compared with the mk square. So let's first write it down, the moment of inertia of this road. It's an I is equals to ml square by 3 because it is going to be rotated from its end point. And if it is going to be rotated from end point, let's compare it with k square. So this is mk square would be equals to ml square by 3. This has gone, and this is k square is equals to l square by 3. This could give me a k would be root of k would be equals to l by root 3 meter. I hope this is clear. Is it? Can I draw one more? A second situation is, let's suppose this is disk having radius r and mass m, radius r. Yes, I want to find out the radius of gyration. So first what I need to do is I need to find it out, moment of inertia of this disk. As I can observe that let's say this is the ZZ axis, then this will be the Y axis. Yes, this is the YY dash, and this required moment of inertia is the parallel to this YY dash. So what I can do is first I required should be is equals to IYY dash plus MD square, that is MR square in this case. For disk IYY should be equals to MR square by 4. So this is equals to MR square by 4 plus MR square, which is equals to 5 by 4 MR square. So now let's just compare it. It's an MK square, that is equals to 5 by 4 MR square. This has gone. So this K is equals to root of 5 by 4 multiplied by R. This is the radius of gyration for the given situation. I hope this is clear. Is it clear? Is it? Are you sure? Are you? Great. Now let's look for one more question. Very interesting question. Let's suppose, see the diagram, that this is one of the ring. Probably this is the center, and this is the another ring. Yes, and both the rings are having same mass as well as same radius, and it is rotating through this axis. Now you can observe this, that for the first ring it is IZZ axis, and for the second ring it is YYY dash. Yes. So what they want that find out radius of gyration for given situation. This is the situation. Find out radius of gyration for the given situation. How will you do this? So what I understand is for the first ring, the situation is something like this. Yes, it is just the IZZ, which could be written as mr square for the ring. And for the second ring, this is, yes, first thing, this both are the ring. Yes, for the second, the situation is something like this. Yes, it's a IYY, which should be given as mr square by 2. So now let's just find out the I total. That should be is equals to I1 plus I2. And when I write this, it's an mr square plus mr square by 2. That should be equals to 3 by 2 mr square. And now my requirement was to find out radius of gyration for the system. So for I need to equate this with not mk square but mk square plus mk square. This is the location where we used to made a mistake. Please understood this very carefully, that I am having a two objects, and when I am having a two objects, I am going to compare this with 2mk square. So let's just compare this and get the value. It's a 2mk square, that is equals to 3 by 2 mr square. This m has gone, and this is equals to k square, which is equals to 3 by 4 r square. So this k could be written as root of 3 by 4 into r. This is the radius of gyration. I hope this is clear. Is it clear? Is it any doubt up till now? Is there anything? No? Great. So let's just wind it up this session over here. Yes, in this session we have discussed three different categories, three different concepts. First was the center of gravity, another was the equilibrium of the forces, and now third is the radius of gyration. Please do remember this. This are having questions based on them at different levels. I hope this is clear. Thank you. Have a good day. Take care. Bye bye.